Hey class, I hope you're having a good week and your semester is wrapping up well. If you have any questions in this class, please feel free to contact me as always. So today I wanted to go over the structure of a project, and it can be multilingual. You would expect it to be, in fact. And so typically you would have at least some representation of persistence, and that typically means a database, some representation of a backend controller, and that'll be written in some language. It may be it may be Go, it may be C#, it may be JavaScript, and then something on the front end. And then that may also be written in the same language as the backend. So in the case of installable applications, that would be the case. You can write GUIs in Java and C++ and C#. Or the modern trend is to have the front end, the view, the presentation layer, to be written in HTML and executed on a browser. The logic being that everyone has the internet now, and if you don't, then it's really hard to consider that person part of your audience anyway, right? Especially if you want to house the data somewhere else. And so for today's lecture, I wanted to address the entrepreneurial spirit that may be present in my class. Part of the appeal whenever I was younger and I was selecting a major with computer science is the potential to get rich, right? It seemed like a fantastic idea. Now, the reason I stayed is because I enjoy the work, but whenever you're dreaming, dream big, right? And so at the time, I wasn't a particularly good writer, so the idea, the premise of finding my glory through the written word didn't seem within reach at the time through that means. So I kind of wandered around and I stumbled into computer science, and I really enjoyed the work. But I would be lying if I said that I wasn't at least inspired by some of the success stories like Steve Jobs and Bill Gates and so forth. And so if there's some of you out there that are quietly dreaming of the same, and you have an idea and you want to execute it, then one of the necessary steps is finding a way to implement it. And something that I've discovered as I've grown in my craft is that you never really know when the idea will happen, and also you don't want to be beaten to market either. So you need to be able to move pretty quickly whenever the time happens, whenever that light bulb goes off. And so I won't say that it'll happen to all of you. I won't say that it'll even happen to any of you. But if if you care to daydream, then you should at least allow yourself to be prepared for that possibility. And so we'll go over it, and follow me. This is a bit tangential, right? But I want to talk about a few things, and then we'll come back to the structure of a project. Right? So this is the application that I'll be presenting. This is the front page, and it has some stuff and some interaction. And a lot of this is pre-built. There's other libraries and so forth. You can log in, register a new user, and navigate around, and that's fine. Most of that's pretty straightforward, and we'll go over it because that's probably what you'll be asked to do whenever you first enter the professional world. But additionally, one of the things is if you do have an idea, one of the things you need to be able to do is to mock it up, to be able to share it and present it as a bit of a story to other individuals. And so you want that time to be as trim as possible, as quick from when the thought occurs until you complete it. And so I want to introduce another concept, so there are speed runs that gamers will do to show how quickly they can beat some of these classic games. And you'll see the world records, right? So this individual set a world record where he beat um, Mario Brothers, the one on the NES, or Super Mario Brothers, in 4 minutes and 55 seconds and 6 tenths of a second, right? And simply astonishing amount of time. So I played this game as a kid, and I started, I want to say, whenever I was 6 or 7, whenever we first got the NES, and it. I would say it took me weeks, but honestly, it was probably a couple of years before I was actually able to beat it. So just it took that long for my skills to develop, and in the meantime, I was developing that ability. And so these individuals, they played it. I guess whenever they were younger. This gentleman looks younger than I am, so he probably played it as this retro game, something that he discovered later on. But he was able to refine his ability again and again and again until he was able to beat it in just simply an astonishingly short amount of time. And part of that is you build this familiarity from doing it over and over again. And if you follow this community, you'll see that some of these individuals set records across multiple games. And so the idea that I'm presenting to you is that you can do something similar with your ability to develop applications and web applications and backend applications and services and cloud functions and database schemas and so forth. And so a lot of it follows certain patterns, and they'll continually recur. And so if you just think about your experience whenever you go to a site, even YouTube, right? So you'll have something that is publicly presented, something that is available to everyone. So you can watch videos and so forth without logging into YouTube. But if you want to create videos, or if you want to be able to interact in the community, like leave comments or like and unlike and subscribe to stuff, then you'll need a user account. And so you have the public site, and then you have an ability for the users to sign up. You have the ability for a subscription, and then the ability to upload content and create content as well, right? And so that's not unique to YouTube. Plenty of other sites have that as well, right? Like if you think about Amazon, you can browse their selection, but if you want to purchase something, you'll need an account, or they might allow you to purchase anonymously, but you have to enter all your data. Okay? And then you can create an account, and they'll keep a history for you of all the things that you've purchased and recommend things for you. And additionally, you can also sell things on there as well, and that will also require an account. And so you have these various roles, whether you're a purchaser, a consumer, or a supplier, or anonymous, and that governs how you interact with the site. And so that's one of the patterns of architecture. Okay? And so you need to be able to present the information that you have, or whatever content you have, allow a means for people to sign up, for people to log in, and then to differentiate on what you make available based on whether or not they've paid you, or they're free, or trying around, or whatever. And so some of that overlaps the business models and so forth. And if you've never heard the term, I would encourage you to look up software as a service. It's a very popular business model for the technology industry, and it's a subscription model. So Netflix is an example of software as a service. You sign up, you pay a monthly fee, and the business is able to use that recurring monthly revenue to maintain a staff of developers and to purchase rights for content and so forth. And the subscription gives them a revenue stream, and the revenue stream gives them credit and also operating cash. And so if you haven't taken any courses in business, that's kind of the summary of what's going on there. And so you would learn a little bit more about some of the ratios about how much you can borrow against your revenue stream, and what might be safe operating things or whatever. But you can understand that concept just as a consumer, as a general user of services. And so, if any of you are to strike it rich sometime in the next year or whatever through the means of software, then it's likely going to be something in that vein where you have some software as a service. And so I don't know whether or not Facebook would actually qualify as that. They are really more of I guess they would categorize as a marketing platform where they sell ad revenue, and they use they are micro advertising. It's very targeted advertising where they have people purchase and they're looking for specific markets, and Facebook is able to identify those groups of individuals that fit those targets. And so that's really what they're doing. And the free service is kind of just an aside, but it's a market research in a sense. But it's still a very useful product, for keeping people connected. Anyway, but again, that pattern, regardless of what the industry is, in this case marketing, it's still very similar. They have the public site, and in this case it's very limited. It's just essentially the ability to register for an account, and then once you're registered, you can interact with them, and if you're purchasing advertising, then you contact them, and so forth. And so again, it's this public and interaction and presentation, these private interactions, and then a bunch of data stored on the back end, something that you view, and something to handle all of your requests and so forth. And so we'll get into that. And so for the front end, I want to recommend a particular YouTube content creator. It's NetNinja, and this is the guy that I use to learn a lot of this content. And so Materialize is something akin to Bootstrap. It's a bunch of pre-built CSS, cascading style sheets, styles, and JavaScript to create kind of a responsive web application. And then his video on React and Redux is really good. And if you want to get up and running, you can consider using something like Firebase, which provides a database backend. And so in that case, if you used Firebase, then you could build and deploy your website and have a database up and running, completely handled by the Google servers. And you could also generate a subscription model as well, where you can only create the account if you have signed up with a valid credit card and so forth, and you charge them. And so that's an additional pattern that can be followed. But without spending any money, you could actually create a product that is completely usable and production ready. But you would have to spend a little bit of money, in that you would have to purchase a domain name. So those are not too terribly expensive, and then there would be a little extra work to configure your application. But you can get most of the way there using very little money, and even working a minimum wage job, probably less than 2 weeks of pay in total in terms of investing into this business. But I would certainly recommend this tutorial, the complete React tutorial, and the Materialize tutorial. And then we'll briefly touch on the progressive web app, this PWA tutorial for beginners, which a progressive web application is it's a mobile application. It's a website that can act in a lot of ways the same way that a mobile application would act on Android or on iPhone, but bypassing the stores, the Google Play Store and the Apple Store. And it's completely opt-in for users, otherwise they can use it as a website. But okay, so I've mentioned those. Now we can come back to the application. And so I'm going to treat this a lot like a code review. So imagine that you've gotten that first job, that all important first job, and you're sitting with the software architect. In this case, it's me, because there's no one else here, right? So I guess that role falls to me. And so I'm giving you a code review. I'm walking you through the code base, and then I'll tell you kind of ways that we can continue the application and so forth. Okay, so let me close out of everything. And so we'll start with the database. So for persistence, you'll need some database. I have used Postgres. So again, my promise to each of you is that everything that you'll see me use can be achieved free. Right? So Postgres SQL download. So you can go and download this, the installers for Windows, Mac, and Linux, and so forth. Right? And then the editor I'll be using is Visual Studio Code. Right? So you can go here and download Visual Studio Code. And it won't compile things for you, but it'll give you this nice editor. And then you can use Control and backtick to make the little console at the bottom disappear and appear, and so forth. Okay, let me change the directory here. Okay, so you'll use that for most of the actions. So whenever you create a new application, you'll need somewhere to store it. And so I'd mentioned that usually this means that you're going to be using multiple languages. It's possible to do everything entirely in JavaScript. You can run a backend server API as using JavaScript. I believe Express is the package that's used for that. You can use React as a front end, which is JavaScript kind of mixed with HTML. You could do it in pure JavaScript if you were, extremely a lot of something, right? And then you could use a NoSQL database, which would basically store the structures using JSON. But the advantage of using a relational database over a NoSQL database is going to be in speed. In particular, a relational database, as the name implies, has relationships. And so you're able to relate multiple objects using foreign keys, and that's something that's not really maintained in a NoSQL database. And so there's going to be a lot of appeal as you start out in terms of going the NoSQL route, because it requires the least amount of knowledge. But hopefully the fact that you're in my class means that you're not averse to learning. And so I would encourage you to take the time and learn one of the variations of SQL, either PL SQL, Procedural Language SQL, which is used by Oracle and Postgres, which we're going to use now, and T-SQL, or Transact SQL, which is used by SQL Server and MySQL and MariaDB. And so most of my work has been in T-SQL, so I'm presenting in PL SQL, which I guess is okay. And so the conventions used by each language is going to vary based on what server you're using or service you're using. So for PL SQL, the naming convention you'll see is to save everything as lowercase. And when we go over the Entity Framework Core, our object relational mapper, you'll see that this does have an effect, right? So in C#, the convention is to use what's called Pascal case, and it's where everything, the first letter of every word is going to be capitalized, right? Camel case is a convention used by JavaScript, where the first letter is lowercase and subsequent words within the variable name or column name in this case are capitalized. And then this is what's known as snake case, and I believe the term came from Python, where the variable, the the words within a variable are separated by an underscore. Right? And so our ORM, our object relational mapper, is smart enough to convert this snake case when using Postgres into this. Right? And so what I want you to notice, so this looks like a lot, right? It's a lot of class files, but this was generated for me. These were generated for me by the ORM mapper. There's a command that you can run, and one of the things I'm going to show you is that it's not really necessary to remember a whole lot. You don't have to remember all of the details, but you do want to remember how to find the things that you're looking for. And in my case, Google is probably what keeps me employed. So here we want, let's see, Postgres, SQL, EF Core, and then database first. And so this will pull up some documentation, and it'll say, okay, you can define this first, or if you already have a database, then you can run this from the command line. So from this little window down here, you would run this command. So .NET, and then we tell it to use the EF package, and the database context, which is it's the code representation of the database. It holds all of the table definitions and all of the foreign key constraints and the not null constraints and so forth. So all of the restrictions on how you are storing that data is stored in the DB context. And then you give a connection string, and you tell it that you want it to scaffold from that. And what that means is that scaffolding is just, I want you to create one of these files for every table that's in my database, right? So over here in the SQL files, when we're originally building the database, we define each one of these tables. We give primary keys and then columns along with their data type. And then we give the restrictions on whether or not it can be null, and typically you want your data to be not null. And then default behavior if that's present. And then on foreign keys, so in the case here, a refresh token is a way to renew an authentication token. So I don't know how many of you use Gmail, but if you use Gmail, then you can sign in, and even if you restart your computer, you come back and you're still, and you go to Gmail, as long as you haven't signed out, then you don't have to log in again. You don't have to re-authenticate. And so some of that is done behind the scenes. So it doesn't mean that your token, your authentication token, hasn't expired. But if you have a refresh token, then it can automatically get a new authentication token for you. And so you can have these short turnarounds on authentication tokens and a longer turnaround on the refresh token. And then it's possible to make a token expired or revoke it. You give it a period of time for which it's valid, and then the expiry date is whenever it's no longer, beyond which it's no longer valid, or you can revoke it prior to that expiry date. And the token is owned by, in this case I've called users authors, and so the token is owned by the authors. And if I delete an author, the foreign key relationship between the token and the author is no longer valid. And so this can't be null, and our foreign key constraint promises that if there is a record pointing to an author, or an author record, that record must be there. And so this line right here on delete cascade says that okay, if that record is removed from the author table, then I want you to delete this as well, right? So anything that was owned by that author, all of the refresh tokens, I want you to make them vanish. Um, and so more typically in enterprise applications, you aren't actually deleting data most of the time. You'll just flag it as deleted. So that way, if someone says, "Oh my God, I accidentally deleted my account. Can you help me out?" You recover the data by the fact that you never deleted it, right? And it is possible to where you can trim it, but you'll make backups of the data, on some regular basis, and then you would recover it from that. So there's all sorts of patterns to consider. But as we scroll through this file, I just want you to notice that there's all of these table definitions and this function here, which defines the behavior of updating the modified date. So anytime there's a record change, these two things here, this is a function definition, and then this is a trigger or an action that is taken on update, which updates the modified value of the new record, the modified date within the new record, and then it does that before update, right? And so as the transaction completes, this value gets updated every time that anything changes on that table, right? And so this is the way to define that, specific to Postgres. So even though it's PL SQL, I don't believe this would work on Oracle, and I know for a fact that it is done differently in SQL Server and MySQL. Okay, so anyway, the idea is that these tables map one-to-one to these records over here, and the scaffolding does that. And these column names map one-to-one to those column names over there. And anywhere that there's a foreign key, you get one of these, I forget the term for it, but it's a shorthand, a way to reference that object which owns a timeline, right? And so the basis of the application that we're discussing today is something that I'd want, or the idea behind it is something that I'd wanted to create for myself for a while. And so if you imagine the process of constructing short stories, then you'll have a lot of different stories, and sometimes they'll relate, and if they do relate, sometimes they'll relate in the form of either intermingled stories or a novel, and so you can construct novels from short stories, and so this application would be a way to manage that. And then additionally, I'm a fan of the Game of Thrones series, A Song of Ice and Fire, from George R.R. Martin, and one of his explanations for having not come out with book 6 in that series is that it's just really difficult to manage the timelines, and so I thought, oh, okay, well, if there was any, I could construct an application that could help with that problem, right? So he writes each of his stories and how long it takes for certain trips, and then it would give the dates, right? But I haven't I haven't solved the problem of a fictional calendar, right? Like all of this is using date time, which is based around the Julian calendar, and so yeah, it's not complete in that sense, and it's not complete in a more real sense, and we'll go over that whenever we talk about unfinished items and so forth. But I just wanted to give you the general idea. So you start with the database, and for me, that's always the easiest thing, is what data do I want to store, right? And it's not always so sprawling. And then you need to create a user, and sure, yeah, this is the password for my user. I'll definitely change it after this video, right? But for the user which lives within the database, so you create users within the database instance that you're running on, and it's the same as anything else. It follows that same pattern: a user and a password, and then the privileges that are available to it, right? And so the database Penman within our Postgres instance houses all of this schema and the data that associates to it. And then this is the user that's able to access it. So whenever we're scaffolding, whenever we're creating our connection string, this thing, the host is going to be localhost, not my host. The database would be Penman. And the user would also be Penman, right? We have both a database and a user named the same, but they don't have to be. and then that password. And so you run that command, and Entity Framework Core will build all of this in the directory that you give it, and if you don't, it'll build it in the directory where you ran the command. And then you need an API, and so that also, again, I don't remember anything. I just remember how to get it, right? So .NET new web API. Right? So it's going to give you the CLI command, the command line interface command, and it's going to give you everything that it can do, which is a lot. But if you scroll to the bottom of these, usually, or somewhere along the way, you'll get the examples, right? So this is what we're looking for. So this is how to create a new console application. This is how to create something in a language other than C#. So this one's F#. This is how to create something in a language other than C#. So this one's in VB. And it's a class library. And so it's written in .NET Standard. And let me take a moment to comment on that. So you'll probably be a little bit confused if you haven't done anything in .NET before. But originally there was just the .NET framework. And that progressed all the way, I think, up until 4.5 or 4.6. And then there was a demand for something that was cross-platform compatible. So something that would run on more than just Microsoft operating systems. Specifically Linux and Mac. And so they created .NET Core, which executes on both of them, on all three, on Microsoft, Linux, and Mac. And they created .NET Standard as something which is compatible to the .NET Framework, which runs just on Windows, and .NET Core, which runs on all platforms. And so every new application I develop is written against .NET Core. And the next version, so it's currently on 3.1. The next version of the .NET Framework will go from 4.8.2 to 5.0. And .NET Framework 5.0 will absorb .NET Core 3.1, whatever, right? So there won't be a .NET Core 4. It's going to jump to 5. And the most confusing thing is that .NET Framework 5 will supersede everything. So it's going to merge those two. So .NET Core will disappear, and it'll just be .NET Framework. But the .NET Framework will go from Microsoft dependent to platform independent. So 5.0 and beyond will run on all three. Until that happens, everything I build is in .NET Core. And I have, if you're wondering, I have written applications and services that run on Linux, and they work really well. I haven't run into any issues. And so that is why it's my recommendation. Additionally, most of my career has been spent using that. But okay, continuing on. XUnit is a testing framework, and so if we wanted to create a test project, and early on you certainly will, until you get the hang of, I shouldn't put in until. You should become familiar with the process of creating test projects, but we won't go over that today. What we are looking for is a web API. And we could do MVC, right? Yeah, sure. This will give you an MVC project. No authentication. Doesn't matter. We're going to build our own authentication. Okay, so you'd run that, and it'll create a project. And that project will have this weather forecast controller. Yeah, I think the command that I used was like .NET new web API, and then I gave it a name. I think it, yeah, Penman API, right? And it created it. It stuck it in this directory, and it created this with the default one. And this gives you an example of everything you need. So these are known as attributes. They can be stuck on a class. They can be stuck on a function. And so the controller, which it is just the request handler, is the entry point for web requests. And so here, we'll go to the user's controller. So whenever you're accessing the website, or the API in this case, you would access the URL. So in our case, it'll be localhost on port 5001. And then users, this is the controller name, will bring you into this controller, right? So it's this part, and then you drop the controller, right? So this maps to this, right? And it's always going to look in the controllers for that. And then the second part is the action, right? So this part, so the route controller pulls from here, and then once you've figured out which class you're in, which class is going to handle the request, you go to the action, right? Okay, so authenticate. So this last part maps to the function name, right? Okay, great. So now we know where to go for the code execution. And so these attributes tell us a lot. It seems like a lot to absorb, and I guess if you've never built a website, which I had not whenever I was an undergraduate, I actually hadn't until several years after I graduated and I was working professionally. Yeah, this is a lot to absorb. But my hope is that in walking you through it, and in some of the ideas I'll present at the end, that we can jump you further ahead than I was. In fact, if I could help you gain the first 10 years of experience from my career before you graduate through some of the exercises that I'm proposing, then I will be extremely happy. But these attributes will tell us whether or not to allow anonymous access. So for people that have no login, or authorize is the other attribute, whether or not it requires credentials, a valid username and password combination. Right? So whenever someone attempts to log in, they don't need to already be logged in, right? We want that to be available to anyone. Anyone can attempt to log in, and then this function will respond and indicate whether or not they have a valid username or password. The HTTP post is an attribute that indicates that they should be posting the data rather than getting it, right? And so one of the tools that I'll recommend you to use is Postman. Let me pull that up over here, right? So Postman download, right? Go here, you download Postman, great. Postman will, without having to generate that front end and go through all of those chores, you can test your API once it's running, right? So this is the URL and port that I had promised for something running on our machine, users, and authenticate. And so our API says that it consumes application JSON, right? JavaScript object notation, if you're wondering what that stands for, right? And it expects the action of post for the controller action of authenticate. So that's our target, right? But it must be accessed with a post. And I brought Postman up because you can submit the data to the controller in action, and then you specify what action it is, right? And so these are the HTTP verbs, and you can look them up. And so get is for kind of data requests that don't really require a lot, but these are the requests of the form. If it's a get request, right, then it'll typically have the question mark and then any additional parameters, right? But if you attempt to access this function with a get, it'll get rejected. It'll say action is not supported or something like that, because we specifically say I only want posted data. And so posted data sends the data in a message body rather than as part of the URL string. And I I don't think it's necessarily visible, but it might be. So the query string is part of the web request, right? So you don't want to send a username and password as part of the URL, just because it's visible to anyone. So in that case, you most definitely want to use HTTPS so that it's encrypted, and then you want to include the sensitive information as part of the body. Now this password is more difficult than than anyone should want to try to memorize. And so I am also going to recommend another application. And so this one is called KeyPass, right? And KeyPass, right? Or, to continue with the trend, KeyPass download, right? You go here, you download KeyPass, or here, other one. Sure, accept, whatever. And download it for Windows 2.4.4. Right. And it'll let you say what website it is, right? So the name of our application or whatever, the username, so our user, and then a password, and it'll hide it first, but it'll generate them for you, and so you can continue to generate them, and you can make them longer and more difficult. And you can even add complexity like uppercase characters and special characters and so forth, and make it as unruly as you want. Right? So that's how I generated these passwords. That's how I'll generate the new passwords that I use after after I post this video to the public. And so this is the message body. It gets encrypted and sent along with the web request. And then it's all of that is handled transparently through the service that is hosting the. It's negotiated between the web browser and the API hosting service, right? So IIS on a production environment, or Kestrel in the case of Linux and development builds, and then. It could also be Nginx if you're running that on a production environment. And so part of this that I'm hoping to impart is that, yes, we cover a lot of theoretical knowledge as part of the undergraduate curriculum, but there is a very large amount of practical knowledge that you'll acquire through industry experience, or if any of you are particularly motivated, then returning to that original concept, we can have the where you develop this application or something very similar as part of a speed run, right? And so we'll go through and we'll create the backend API, and then we'll go through the startup and we'll configure it, right? How to read in all of the data, how to set up JWT authentication, JSON Web Token authentication, setting up that scheme, how to set up the configs for it, how to execute it, how to install the local SSL certificate, and then how to create this from create React app, right? So there's a command, npx create React app, and it'll create a basic project for you. Anyway, so that's the overview of the back end. It's doing a lot. There's a lot of specific things that happen, and you'll notice that in the user's controller, as we were going over everything, that here we're not connecting to the database. We're not really doing a whole lot. It handles the web request, and it does so pretty cleanly in my estimation, but that's just my opinion. And it touches on a concept that I also want to discuss, which is dependency injection and inversion of control. And these are classic patterns. Um, and inversion of control is one of the solid design principles, if you've gone over that. And essentially, each one of these interfaces is instantiated in startup whenever we configure the services, right? And so as we go along, or in my case at the bottom, we'll add singletons and scoped references, and I forget what the last one is. It's services.add singleton, scoped, and instance. Session, right? Yeah, that's another one. Okay, so one of the trends, and something I would recommend, is you'll have to decide between like how you handle your web services, right? And so I would recommend that getting started, and essentially for my entire career, to use REST-based web services, or in this case, back-end APIs, which are stateless services. And so being stateless doesn't mean that the user doesn't get the experience of having state, right, as we'll see when we go over the user interface. But it means that it's not maintained on the server. And so there's it's an elegant solution, and in particular, it's a scalable solution. So, this being discrete, and kind of this whole time we've been building up to the idea of counting, right? So as you count to the number of users that Facebook or Google or Amazon has, you realize that it's not really practical to have server resources set aside for their users as they try to figure out whether or not they're done using it, right? Like it's just an impossible problem to try and manage. The easiest thing is to have a bunch of identical servers, thousands of identical servers, hundreds, tens, two, whatever number applies to your product, right? That are completely unaware of what the user has been doing, but they handle the situation in the same way every time, right? And they pay no particular attention. The consumer, the user, the front end, whatever, has their attention only so long as it takes them to handle the current request. And so authentication is maintained by having in this case, a common secret across them, so that they're all signing these tokens, with the same. And in the case where it is necessary to maintain active sessions, you can use something called WebSockets, and it's still the exact same concept, where it's only handled by that particular service for the life of that particular interaction. It's just that the interaction doesn't close whenever the request is done. It's kept as an open channel so that you can go back and forth. And that was one of the patterns that I'd hoped to implement, but the video is already running a little long, and so the implement it as we go idea is not going to work on this. But again, for those of you that are really interested over the summer, we can go over that. And so you can use a WebSocket to maintain a chat session or anything that requires a back and forth. So if you think about Google Docs, Google Docs provide the ability for multiple individuals to edit the same document at the same time. And so you could use something like WebSockets to create that experience. And I would like to go over that at some point. And so the way to do that in .NET Core is to use a package called SignalR, and that's supported in React. And I do have a working example of that, but we won't go over that today. Anyway, so what we were talking about was inversion of control. And so you register the interface, and then, so interfaces in .NET typically begin with I. It's not, enforced by the compiler. It's just a convention agreed upon by the development community. And then the concrete instances, same name typically, but without the I. So this interface, and you cannot instantiate an interface, is handled by this instance, this class instance. Right? In this case, author service, this interface is handled by this. And so you're asking, okay, well, where did we declare the variable and new? We're just giving these class names and interface names. Well, that's the beautiful thing about inversion of control containers, and why I really recommend you using them. You don't instantiate it. So this scoped instance knows to, whenever this interface is required by a controller, for example, here we say we want that, and in another place we ask for an automapper instance, right? That it knows whether or not to use the same one for every web request, as is the case here when we're asking for singletons, right? So it uses the same config instance regardless of any one of a million different users, right? Or whether or not to create a new instance, which is exists just for the life of that particular request, right? And so if something is immutable, if it never changes, regardless of who is using it, then it should be a singleton. There's only ever the one instance, and by this declaration here, the IOC container knows, okay, we only are ever going to need that one instance. Here it says, okay, I'm going to need to create a new author service anytime this interface is required by one of the controllers or anything else. And so it all kind of magically happens, right? You just declare how it should handle it, and then at runtime, it will go through and it'll use reflection to look at the code and say, okay, all of these interfaces are required. I need to create instances of those and provide that. And if it's not able to satisfy any one of them, then it dies. And so through development and testing whether or not you have correctly declared everything. But if you've done it right, then everything is well handled. And it's built in such a way that you can create test cases around it using something like XUnit or InUnit. Okay, so that's the back end. We've gone over the database briefly, and we've gone over the back end. We mentioned that this was created through npx create react app, and so it'll generate these public folders, and the public folder includes an index.html, which is what gets served up whenever you just go to a website without anything at the end, right? So google.com is going to look for an index.html on Google servers. Right? Like it's just the default file that gets served up, right? And so this follows the format of a typical HTML file, right? And then we've included some style stuff here. So I mentioned materialize, which the NetNinja channel goes over in pretty good review. And then you can go to the Materialize website to get additional details. And they have certain icons that are used throughout the application. But you'll notice that there's not anything in the body, really, other than this no script fallback, which is shown if they don't have JavaScript enabled, and this root. And so that is the pattern of a single page application. So in order to create something that is responsive and a better user experience, a smoother user experience, you have all of the page movement, like all of the interactions, handled completely on the client side through JavaScript, and then calls out to the server or happen asynchronously, and then when the response comes in, you update the state, and React is reactive to the state updates, right? So you have a client-side state manager, which is for the purposes of this project, we're using Redux, and React components which subscribe to particular portions of that state. And whenever it sees it changed, then the components update. They are aware of how they're supposed to behave based on what that state is. And so it is reactive, and that's where the name comes from. Right. And so the public portion isn't really all that interesting. Whenever you build a production build, it makes certain substitutions and then sticks it in this folder, and then that is what you deploy to your IIS server or Apache or Nginx or whatever you're using to host. And so the entry point is going to be the index file, and you'll notice that these, for one, they're not JS files, which are JavaScript files. JSX is the React extension, and then TSX, or TS is for TypeScript, and TSX is the React TypeScript inclusion. And so I would recommend that since you're getting started now, that you also take a little bit of time to learn about TypeScript as well. It is a superset of JavaScript that enforces typing at the time of it's not compilation, it's translated, so they call it transpiling. And so at the time of transpilation, transpiling, whatever. Anyway, and so it's pretty smooth for the most part. You don't notice a lot of the changes, but some of it is enforced, and I noticed that some of my files changed. Anyway, the entry point is the index file. And so this strict mode is, I guess, React's way of saying to enforce the TypeScript stuff. But typically, it would just start with app. And then when you add Redux, you add the provider, and you say the store is the store, which is created here, and it references a root reducer. So the state management is handled by reducers, and that's the Redux pattern. So here we go into store, and we have the auth reducer and the root reducer. The root reducer will declare what is available whenever you go to a connected component, right? And so all of my components are connected, all of the declared components. You don't strictly need to follow that, but based on what I was able to complete for this, they were connected, and there are two parts whenever you connect them. The optional dispatch, which is functions that typically update state, or in this case I have one that accesses state. I really didn't need to include it here, but we will just as part of the patterns, right? And this one, so this is the global state object, or the root state for Redux, and this auth here corresponds to what we declared here, right? And then that provides information of the authenticated user object. And so I really do need to wrap this up, but if any of you have further interest in this, please do email me, and I will create a series of follow-ups that allow you to create a project similar to this. And I would like to challenge you to speedrun with me. And so it's creating the same thing over and over again, but it's also drilling it, right? There was there were a series of kung fu and karate movies whenever I was a kid that I really enjoyed, right? And you know, the Karate Kid, and they have all these mystery actions, and you learn that he's been learning, you know, karate the whole time, right? But you know, it can be like that, right? So for now, until you really understand, you know, how to progress yourself and how to identify the work that will be beneficial to your own development, there are just certain directions that I can point you in and say, okay, well, if you just do this and you learn this particular skill, it will come in handy. You know, just trust me on that, right? Anyway, so Yeah, I don't know how much further I'll be able to go because I kind of need to post this video. But if you are interested, I will post this on GitHub, and I'll make an update later on that makes it available with the link to it. Then email me, and I would love to create those videos, and if I will, if at least one student is interested in doing the work over the summer of kind of maybe not repetitively doing it, but at least challenging yourself to do it a couple of times and go through the motions of it, and have something that you can create and you can try to create manually, where you type everything out. You're not copying and pasting. You're not just cloning a repository, but you're going through and you're learning the lessons of creating this structured application, so that you can host it and create something that you can host on your own environment, and then learn to deploy it. And if you can do that, and a lot of you are freshmen, you have 3 years to do that, then by the time you graduate, you will be 10 years ahead of where I was whenever you graduated. And so it's by no means required. It's beyond what I would even consider senior level college stuff. I would consider this senior level development stuff. But if you can start there, I think that's a magnificent place to be. So in the end, I didn't get to go over nearly as much as I had hoped to in terms of this, but I'll post the code, and to anyone that's particularly interested, we can go into it in a little more detail, and I'll post shorter videos that break it down, and if there is interest, then additional videos that go over creating handling the certificate management for SSL and so forth. And so there really is a lot to learn and a lot to build upon as you grow in your career. And so hopefully this gets across that there is so the theory is very important, and it'll tell you exactly how bad you will crash and burn whenever your product takes off, right? Like, it's kind of what Discrete 2 is all about. Like, well, it's great, you got it up and running, but it can't possibly support this user base, and this is why, right? And so I wanted, I suppose, to make a lot of these concepts more tangible, just by exposing you to this, right? The underlying product, and so this follows and satisfies a lot of the patterns that you will run into again and again in your career, and hopefully seeing this concrete implementation and the structure of the project will give you an idea of what it is that you're trying to manage, and trying to understand how it scales. Right? Okay, that does it. It's time for me to post this video. Again, I really enjoyed having all of you, and if you have any interest in spending the summer, creating projects and kind of beginning to instill the discipline of product development, then feel free to email me, and if there's any if there's even one of you out there that is interested, then I will definitely make those videos. All right, have a good evening.